Hello guys, welcome back to the channel and thank you for 10 subscribers. It's a lot to me now. So today we are going to solve question longest subarray with sum k. So in this question we are giving a array and we have to find the subarrays which is sum equal to k, and we have to maximize the subarrays, like which subarray gives the sum k and size is maximum. Yeah. So the one approach of solving this question, so in this example the array is given this, then we can say that this is the subarray, this is the subarray, all the subarrays, and we can say that we have to find the sum of 15. So 10 and 5 15 makes the sum 15, and we can say the size of 2. Then we can say the 5 2 7 1 also 15, and its also sum is 4. Then we can say that some other 10 and some other mix, and we can say that the this one is the maximum which gives sum as 15. So this is the answer. So we can say that first approach is the brute force approach we can apply, and find all the subarrays. So I equal to 0, I less than n, you can say that I less than n, and I plus plus. So and I'm saying sum equal to 0, and I'm saying for and I equal to j equal to j equal to I, j less than n, and j plus plus, and I'm saying sum plus equal to I think arrj, and wait, and I'm saying max sum equal to max of max sum and sum, and then we have to return max sum as the answer, and I'm saying sum and int max sum. Let's compile it and this check is correct or not. So the output is 19 and we want output is 4. So what I'm doing is I'm finding max sum. We don't have to find max sum. We have to find sum, and first to find sum, then saying if sum equal to k, then you have to find max sum, or not max sum. Sum equal to k, then j minus, then the index is j minus I minus 1 plus 1, sorry, because the 0 base indexing, so it's plus 1. Yeah, let's submit this and check it's correct or not. Is running for 189 task cases, then it's give TLE. Why is give TLE? Because the time complexity taken by this algorithm is big of n square, and we have to optimize into big of n, so that's why it's give TLE. Yeah, so we have to optimize it. So for storing the values of the sum of the error, we can say that we have to use some data structure. So I'm using unordered map for this. So say that this is not good for the approach. Another map, and yes, this is another map, and I'm saying sum equal to my sum and max sum also. So both are 0, and I taking all the values of the array. So I less than n, I plus plus. Okay. Now I am saying sum equal to ARRI. So I am counting every value of the ARR as sum. So first some value is 10, then some value is 10 and 15, then some value is 10, 7, 17, then some value is 24, then so on. It's moved. So and now I am storing the sum value as indexes. So here sum is 10. So 10 sum is 0 index, sum is 10. Now at 15, so at one index sum is 15. Now at second index sum is 17. Now at fourth index sum is 24, like that. So I'm saying MPP of sum equal to I. So ith index sum is stored in, so sum at ith index stored in the map. Now I'm saying that if let's say what the sum value is 15, then say that this is the answer. So I'm saying if some value is somehow k, then we can say that our max sum equal to maximum of either of max sum or either of let's say here value is I, then I plus 1, because it's 0 base indexing. So the maximum of this will store in the sum. So it's easy, but if sum is k, then we can say that if the sum of these values is k, then we can say that these three is the answer. If we can say that these four values, the sum is k, then we can say that the four values, so it's 0 1 2 3, so 3 plus 1 4, four values, because zero based indexing. So I plus 1, here I plus 1, I plus 1, and which one is the max, because first storing these values k, but there is some negative element, there is some negative element, then we can say that the now also sum is 15. We can say that now this I plus 1 become 1, so we have to use this. Now now uh, now the approach of using map is that let's say this sum is 15. Okay, now we got sum is 15. Now the sum is 15. Now we moves here. We store sum as 10 0, because the 15 at 1, then we can say that now sum is 10 5 15 to 17. So we, what I'm saying is here, sum is 17. So we can, I'm saying that if there this element is equal to 15 or not. If there is 15, then we can say that this value. If like we move here and we can say that the sum of these two values is 15, then we can say that the remaining elements present in the array. So we can say that like sum. So here we find the sum of all these values. Now I am saying that if this value 15 is present here, then we can say that if this the difference between these all values minus this value 15 is present before, then we can say that sum of these values is 15. Because if the sum of these values is 15, then we can say that the difference between these two is equal to the k, because this is x. Let's suppose this is x, and this all values is k, then we can say this k minus x, or we can say that this all value is sum, and let's suppose this is x, then this will become sum minus k. Let's suppose this is k, then this sum minus k, this value is sum minus k, this is k, or all values is sum. As simple. So I'm saying that into, you can say that val equal to sum minus k. So sum minus k is what? All the way sum here till sum is 24, and sum minus k is 24 minus 15. Sum minus k is 24 minus 15, which is 9. So I'm saying that if there is 9 present, so 9 present till here. Let's suppose this, let's imagine this, the sum is 5 to 7, so 7 14 14 and 15 and 25, so sum is 25. Now I am saying the sum of all these values is 25. Now I am saying 15, so sum till here is 15, so we can say that this will form, so we can say that sum is 25, now k is 15, so we can say that if these values make sum 15, then we can say that 10 present here, so we can say that the difference of this is present here, then this value will definitely make values of k. So I'm saying if map.find, if you find val somewhere previous mpp 10, so if it's present in the map, then we can say that, definitely say that there will be k. Now what's the values of this? So we can say that this is I, so I minus, we can say that till here we can say that 10 at index what 0, and index 0 is stored where? Mpp of sum. So mpp of val, it's not sum because mpp of val as is the at that uh, time as we did, and we have to some max, so we can say that max sum equal to max of either of sum, either of max sum or either of time, and we have to return max sum. Let's run this, check is correct or not. My bad. Yeah, let's submit this and check is correct or not. So there is some problem. Where the problem occurs, I will tell you. So let's say there are values, there are, let's say, 4 values, and we have to sum is 5, then the answer is 2 0 0 and 3. Let's imagine the condition this, and we have to make some 4. So let's say what this code do wrong. Mm, let's okay, let's just, so there is some error occurs here, I will tell you. So like let's say it's 3, not 5. Let's say we want to make some 3. let's say we want to make some 3, so there is output 1 and expect output 3. So what happen at some 3, let's say the sum is 2, it's not equal to 3, so it's not counting. I say it's not equal, then it's move. So 2 at index 0, so what is store? 2 0, then again 2 1, then again 2 2, then again it's a the previous sum is 3, then it's saying it's 3, it's saying like sum is total 5 and 5 minus 3, 2 is present in the array or not? It's saying yeah, 2 is present, but 2 is present at what index? It's saying 2 is present at x 1 2, 2 is present at 2 index, so it's saying I is nothing but 3, 3 minus 2 is 1, so temp is 1, so it's saying 0 and 1 max is 1, so it's a temp 1. But what we, if there are zeros, then we can say that this will just count mpp of I increases when there is 0 because some of this 0, but we don't want it. So we can say that if the values is previously present, then don't update it now. We can say that if mpp dot find, if mpp dot find what sum, if it is present, so is equal to mpp dot end. If it is present, then dot push. If it is not present, then you just have to push it. If the value sum is not present, if it is not present, then you have to push. So first is saying it's not present, so as for 2 0, then he's saying again 2 is present or not? 2 is present, so it doesn't push. Now let's run this and let's submit this. So yeah, problem solved successfully. So yeah, this is the approach for solving this question, mapping approach. So what we did, we just initialize two variables, sum and maximum, and for sum we will just making the sum of the every elements. And just remember one point, we are storing how much this point sum and what index sum is what. So what index sum is what is stored here, and just remember that if there are zeros, then be careful about zeros, because they will just add up to the value. So checking if they are previously present, then don't update it. And just we are saying if the difference between these two values, so this is 15 until here sum is 20, so okay, that 20 minus 50, if their difference is previously present, then we can say that definitely say that there is something that sum is equal to k, so we have to find this something. So something is nothing but this value, and minus till where the sum is is different, so we can say that this is stored in mpp of val, because we have to find file, so that's why we are returning it. So yeah, this is for the video.